We are here to present our project Automated Soldering Machine. Soldering components on a printed circuit board is a basic thing we all do in our projects related to electronics. We spend a lot of time in soldering ICs and other electronic components than designing and testing it. So we felt it would be great if we have an automated machine that does the soldering process. The main objective of our project is to make a computer controlled soldering machine that can solder through hole components placed on a PCB. The machine will take the coordinates of soldering points from a file generated by a EDA software like Eagle, Altium, etc. The soldering points will be processed and fed to a microcontroller based device. Then the machine will do the process and get our work done. Moving on to the workflow of the machine.
The first step is to design a PCB file using any of the PCB design tools such as Eagle, Altium Designer, etc. The next step is to export the CSV file which contains information about the coordinates of points in the PCB. And the next step would be to launch the solder app that we indigenously developed and choose the destination of the CSV file. The next step, this will be done by the application itself. It will extract the soldering points from the CSV and then calculates the steps required to traverse from one point to the other point, and then calculated results are sent to the ESP32 wirelessly, which receives the command and controls the actuators. And this step is repeated until all such points are soldered. We have designed a PCB in Eagle for testing. Upon pressing the manufacturing tab, we get to see this window in which there's an option to export the coordinates of each point as a CSV file. After we press this, we get a CSV file that has all the coordinates. We then feed the CSV file into Solder app, which launches a program that extracts the coordinates of only plated through hole, ignoring vias and non-plated through holes. These coordinates are then converted into a list, which we rearrange so that each point is very close to the next point. That improves the time taken for soldering as well as the efficiency. So next, we calculate the relative position of each point with respect to the other by subtraction of x coordinates of each point and their y coordinates. So these differences are then converted into number of steps required for the stepper motors by dividing the distance by the resolution, which is 130 micrometer in our case. Then every pair of numbers are sent to the ESP32. After successfully soldering, the next pair of numbers are sent. This process is repeated until all the points are soldered.
Good afternoon everyone, myself Kasi Vishwanathan, and I'll explain the hardware setup of the machine. This is the front view of our machine. And as you can see, we have used two old CD drives, one for the x-axis and the other for y-axis. And this one is to control the x-axis, and the one on the top is for the y-axis. And also on the y-axis, we have attached this black color mechanism for z-axis up and down motion. And the soldering iron is attached to this z-axis. And this is the feeder part of the soldering iron that feeds the solder wire to the needle tip through an extruder mechanism. And this is the extruder mechanism. As you can see, we have used two DC gauge motors in which we have attached the 3D printed blue color gauge, which extrudes the solder wire from the solder spool. And also a rubber band is attached around the gauge to make sure that there is no gap between the two gauges, and also the solder wire is extruded properly. And this is the circuit setup. As you can see, we have used SMPS to power all the equipment, electronic equipment, including the soldering iron, and we have used two A4988 stepper drivers to control the stepper motors attached to the CD drives. And this is the L298N motor driver, and this controls the extruder motors and the Z-axis motor. And the black color module is the ESP32, which acts as a brain to this. This is the working of the extruder mechanism. We have used an IR sensor to regulate the flow of solder wire as shown, and also the extruder motors are turned on until two pulses, or you can say two black color tapes are detected by the IR sensor.
Good afternoon, judges. I'm here to explain how to use this GUI application. First, let us open the solder app. This application is console based. We can see the outputs from the printed from the Python file through this window. I have used this as a reference. In final application, this will not be visible. This is our main application. Now we have to select the appropriate port for communication between ESP32 and PC. We need to select the port named CNC PCB, which can be viewed in Bluetooth settings. For me it's COM13. After setting the port, we need to calibrate our machine, which can be done using these buttons X, Y, X minus Y, Z and solder, which is used to calibrate the stepper motors and the soldering iron, as well as the extruding solder lead, everything. And then we need to paste the location of our XLS file, which we need for the respective board that we generated from Eagle software. The space provided, and then we need to select the total number of boards, let's say 5. On clicking proceed, the file path, the number of boards coordinates with respective radius are printed in this console window. In the build confirmation tab, the total number of boards, the total number of holes, the total cost are displayed. On clicking OK, the machine starts soldering. After completing 5 boards, the total number of boards completed is 5 will be printed, and then we can reset our application to clear all the inputs we gave. There are 3 menus called file, tools and options. In file there is exit, in options there is an about, and tools we select the port and COM port. In there will be a folder called builds in the desktop, in which there will be a text file on respective date when we build. In that text file, the time, the file name, the number of holes, the number of boards, the cost per board and the total cost will be saved. And the other, for other bills, it will get appended on the same day for respective days, and each text file is created for each date. Now we can reset the application, and on clicking exit, the application closes and the console window terminates. Thank you.
This is the working video of our machine.
Some of the pros of this machine. This is fully automatic machine. Once we place the components, it will automatically do the process, so there will be no human interference. It can be operated wirelessly using Bluetooth between ESP32 and PC, so the machine need not be connected to the PC always. Since we are using SMPS, the power consumption of machine will be very less. We have used a GUI app as you saw before. This allows you to easily use the machine. Some of the cons of this machine. The feeder tube must be aligned properly with the solder tube, else the solder wire will not come in contact with the soldering tube. The precision needs to be improved. The current prototype you saw is restricted to solder 4 into 4 cm PCB only, and there is no reset or emergency switch in the hardware setup. The machine works even if there is no PCB board, so a sensor like LDR must be installed to detect the presence of